So we can generate 3D solids by taking a function, so in this case, this function f of x, that red line, and we can actually rotate it around the axes to create a three-dimensional solid. So this solid is kind of like a vase shaped on its side, and we can find out this volume of this solid by taking a look at each slice. Okay, so if I take each slice, every slice is going to be a circle. So if I slice it through like that, okay, so I don't know if you can see that, but slicing through like that, we're going to get the cross-sectional area is going to be the circle. So I can calculate volume by just basically using the principle that volume is area times thickness. So if I can find the area of each of these circles and multiply its thickness, I can find the volume of this slice. I can find the volume of another slice over here. I can stack all these volumes together, or in other words, integrate, okay, add up all these slices, and I'm going to end up with the volume of the whole object. Okay, so that's the idea around calculating these solids. Okay, we want to basically take this idea of area times thickness gives us the volume of this piece, and we're going to integrate or add up all those pieces to get the volume of the object. So first of all, it's good to kind of identify or recognize what these shapes look like. Okay, so visualize this shape. This line being rotated kind of gives you this vase shape on the side. So then to do it using these discs, in this case we're going to get circular discs. Okay, what we want to do then is to find out the volume. We're just going to take the volume of this one piece. Okay, we're going to take the area of this disc and multiply it by its thickness. Okay, so we've got the area of the disc times the thickness gives us this one piece here. Okay, so this is going to be calculated by pi r squared times the thickness. Well, the radius of that disk really is going to be this f of x. Okay, the height of this disk, or the radius of the disk, is the height of the graph. So that f of x then represents the radius for which we can calculate the area of that circle. So then when I do this, I want to sum up all those volume slices. So I take all those circles times dx, or delta x, and sum them up. And if I want to do this more precisely, I make my delta x go to 0, which essentially becomes dx. And summing it up means I'm integrating. So my integral looks like this to calculate the volume of that rotational object. Okay, well, let's try one here. So we're going to take this graph, y equals x squared. Okay, so I'm going to take this graph, y equals x squared, and between x equals 1 and x equals 2, I'm going to get this area here. And I'm going to take that area and rotate it around the x-axis. So I'm going to generate kind of this shape like this. Okay, so that's a circular shape here. Okay, it's not the greatest drawing, but we're going to end up with this shape that kind of looks like this. It's going to be a circular face on the front, a circular face on the bottom there, and this area, this volume is going to be generated here. Okay, I've given you a better visual on the animation that you're going to see next. Okay, but there it is. We're going to take this area and we're going to rotate it to give that volume. Now to calculate this volume, what we're going to do is take each one of those slices as a circle. Okay, we're going to slice every circle here. So to calculate the volume of the circle, we're going to do this. We're going to do pi times r squared. Well, the r is represented by the f of x. So I'm going to do pi r squared, and then I'm going to give it some thickness dx. Okay, and I'm going to integrate that from x equals 1 to x equals 2. And in doing so, I'm going to calculate the volume of this whole object. So this represents the area of the circle times dx gives me the thickness of that disk. And if I add up all the disks or integrate, I'm going to get the volume of that solid. So it looks like this. I'm going to do v equals, I'm going to take the pi on the outside, the f of x. In this case, the f of x is going to be x squared. Okay, so I'm going to take x squared and I'm going to square it. So there's my pi r squared times it by dx. Okay, when I integrate this, I'm going to end up with this integral x to the power. So this is from 1 to 2, x to the power 4 from 1 to 2 dx. Okay, the antiderivative then is going to be x to the power 5 over 5, and I'm going to integrate that from x equals 1 to x equals 2. That's going to calculate all those slices, all those discs, add them all up from 1 to 2. Okay, so then when I plug it in, I get pi. This is going to be 32 over 5 minus 1 to the power 5 over 5. So the volume works out to be 31 pi over 5, and that's going to be units cubed. Okay, so there's my volume units. Okay, so we can take a look at another one here. This one's a little bit harder as we're not rotating around the x-axis anymore, so we have to kind of think of how this is going to look. So first of all, my equation is going to look like this. Y equals x squared plus 1. And I'm going to have my line, I'll do this in a different color here. My y equals 5 line is right there. Okay, so y equals 5. And I'm going to rotate that shape around that line. Okay, so what's that going to look like? Well, first of all, I need to be able to calculate these slices. Okay, so these slices are going to be rotated to generate the discs that I want. So that slice here, if I want to find out the length of that slice, which is essentially going to be the radius of which I'm going to rotate, okay, the length of that slice is going to be y equals 5 minus x squared plus 1. Okay, so I'm going to do this here. So minus x squared plus 1. Okay, this is going to give me this radius length here. So that's my r. So that's r. So I need to do pi r squared. Okay, that's going to give me the area of the circle that's going to generate. I want to give it some thickness like I've given it in the diagram here. So I'm going to give it some dx thickness. And then I want to integrate all that, all those slices. There's going to end when I rotate them and multiply by pi, I'm going to get all those discs. And I want to integrate it from this point here to this point here. Okay, so I got to figure out what those coordinates are. Where these intersect, where y equals 5, x equals -2, and +2. So I'm going to integrate from -2 to +2. So this will calculate my volume. I'm just going to move this over a little bit. Okay. So all this calculates volume. Okay, so again, what I did was I took this length, and maybe I'll change the color there to make it stand out a little bit more. There's my radius. Okay. And my radius is going to be this expression here. Okay, so there's my radius. All that inside there represents my radius, so I'm going to take that radius. This line minus this point, okay, this point minus this point will give me that length, radius. I'm going to square it, times it by pi, and give it some thickness, and sum it all up, or in other words, integrate. So there is my integral to solve for my volume. So I'm going to then take my pi on the outside from -2 to 2. Okay, I'm going to simplify this expression, so it's going to be 4 minus x squared dx. Okay, to integrate this, it'll be much easier if I expand it. Okay, so it's going to be 16 minus 8x squared plus x to the power 4 dx. Okay, so the antiderivative works out to be 16x minus 8x cubed over 3 plus x5 over 5. And I'm going to integrate that from -2 to to positive 2. So plugging in those values then, I'm going to calculate my volume equals pi, and 16 times 2 is 32, minus, that's going to be 8 times 8, so 64 over 3, plus 32 over 5, okay, minus, and that's going to just be the opposite of that, so it's going to be negative 32, it's going to be plus, so negative negative gives me plus 64 over 3, okay, plus, or sorry, it's going to be minus 32 over 5. Okay, so basically it's going to be double that value. So if I just plug that into my calculator here, okay, it's going to be 32 minus 64 over 3 plus 32 over 5. It looks like it's 512 over 15. So it's going to be 512 pi over 15 units cubed. Let me just write that out a little bit better. 512 pi over 15. Okay, so there's the volume of that object. Okay, the next video is going to just show you, if it was hard to visualize what those objects look like, the next video will just kind of show you what those shapes are going to look like.